Hello, scholars, and welcome to Mr. Chambers Teaches HMH into Math for 5th grade. Today we are working on Module 1, Lesson 2. These are pages 9 through 12 in your Unit 1, Module 1 to 9 workbook. In this video, we will review the objective, spark your learning, build understanding, and step it out problems for this lesson, and a few select questions from Check for Understanding and On Your Own for review. Please feel free to skip around in the video to find help working on the particular problems you may need help on. For Lesson 2, we are use powers of 10 and exponents. Our objective is, I can rewrite expressions involving the product of a one-digit number and a power of 10 as a whole number. Spark your learning. A local business has set up a website to raise money for a playground. Each donation is $10. For the first 10 days, the account receives 10 donations each day. How much does the account receive the first day? How much does the account receive after 10 days? Explain your thinking. In looking at this problem, we see that each donation gives us $10. The promotion goes for 10 days long, and each day they receive 10 donations. And the first day, we have 10 donations of $10 each. If I multiply 10 times 10, I get a product of 100. They receive $100 of donations on their first day. If we extrapolate and think how much do they earn after 10 days, we know that each day equals $100 in donations. We'll multiply this times 10 days to find out how much money they earn after those 10 days. If I multiply 100 times 10, that moves my place value one digit to the left over to the thousands place value, where I see that they have earned $1,000 in their first 10 days. There's multiple ways of representing this. This is just my way of showing it, but maybe you and your partners may have come up with a different way of expressing how much money was raised over those 10 days. Moving on now to page 10, where we are going to be building our understanding with question number 1. Question number 1. One bag of playground sand is shown. How many cubic inches of sand are in 10 bags? So if I look over here, I see that one bag of sand contains 1,000 cubic inches of sand. For problem A, I want to use multiplication to show the number of cubic inches of sand in 10 bags. And how many cubic inches of sand is this? One bag of sand contains 1,000 inches of sand, or cubic inches of sand. If I multiply this times 10, I find that my total value is 10,000 cubic inches of sand. I can either write my units as CUIN or IN with an exponent of 3 to show cubic inches. Over here on our right in our vocabulary section, it says you can represent repeated factors using a base and an exponent. The base is the number used as a repeated factor. The exponent is the number that shows how many times the base is used as a factor. For instance, 10 times 10 times 10 is 3 factors of 10. My base is 10 to the third power. Using my exponent of 3, that's another way of representing 1,000. When we are asked to write it in exponent form, 1,000 would be written as 10 to the third power. In word form, we can say the third power of 10, or 10 to the third power. So in question B, it's asking, how can you write 1,000 as a product using only factors of 10? Explain how we know. So as factors of 10, we have 10 times 10 times 10 will give us a product of 1,000. We can also write this as 10 to the third power to represent 1,000. I apologize for putting my comma in the wrong place. 10 to the third power equals 1,000. A handy trick to remember with our exponents is as long as we are in base 10, the exponent that we have here tells us the number of zeros that we should have in our solution. So if I am doing 10 to the third power, that 3 as my exponent says that I should have 3 zeros. Question number C. How many factors of 10 are needed to write 1,000 as a product using only factors of 10? How many factors of 10 are needed to write 10,000 as a product using only factors of 10? To represent 1,000, we know that it is 10 times 10 times 10, as shown in problem B and the Connect for vocabulary. This can be written as base 10 with an exponent of 3. 10,000 is 10 to the fourth power. I can count the number of zeros that are here, and that will tell me what exponent to put on my base 10. So I have 4 zeros in 10,000. It would be 10 to the fourth power. Question D. How can we write the number of cubic inches of sand in 10 bags in exponent form? Well, we found in problem A that if we have 10 bags of 1,000 cubic inches of sand, that our total product is 10,000 cubic inches. In the number 10,000, I have 1, 2, 3, 4 zeros. So as an exponent, I can write that it is 10 to the fourth power. Question E. A power is the number that results from repeatedly multiplying a number by itself. How can we write the answer from part D in word form? In word form, we can write it as 10 to the fourth power, or the fourth power of 10. Either are acceptable. Moving along now to page 11, where we are going to do our step it out problem. For step it out, it says, a company sells 10 to the sixth power cell phones per week for 7 weeks. The total number of cell phones sold is 7 times 10 to the sixth phones. How many phones is this, written as a whole number? To help us step it out, we're going to work through the exponents, multiplying 7 times 10 as our base against multiple exponents. Starting with 10 to the 0. The 0 exponent says that I have 0 zeros, and therefore this problem is represented as 7 times 1. 7 times 1 is going to give me a product of 7. Anything times 1 will always be itself. Next down, 7 times 10 to the first power. The 1 as an exponent tells me that I have 1 0 because we're working with base 10. So I'm going to multiply 7 times 10. This gives me a product of 70. As we carry on down, 7 times 10 to the second power is equal to 7 times 10 times 10. The exponent here, 2, tells me how many zeros I'm going to have behind my number as long as we're in base 10. So 7 times 10 to the second power gives me a product of 700. Following the pattern, I have an exponent of 3. I'll go ahead and write 3 zeros here and multiply 7 times 1 to give me a product of 7,000. In 7 times 10 to the fourth power, I have 4 zeros, so I'm going to write 4 zeros and put my 7 in the front. This gives me a product of 70,000. Next step, 7 times 10 to the fifth power. That 5 tells me I have 5 zeros, and I multiply 7 times 1 to give me a total of 700,000. Lastly, 7 times 10 to the 6th power tells me that I have 6 zeros preceded by a 7. This answers question B and our overall problem, that the total number of cell phones sold over the course of 7 weeks is 7 million cell phones. Now we're going to move into the odd number questions for our check for understanding and for on your own. Starting off with question number 1. The attendance at a music festival is 100,000. Write the number in exponent form and word form. As an exponent, I know that I have a base 10, and then I can count the number of zeros in 100,000 to figure out what my exponent is. I have 1, 2, 3, 4, 5. So in exponent form, the attendance at the music festival of 100,000 is 10 to the 5th power. In word form, I can say 10 to the 5th power. On to question 3, I am multiplying 7 times 10 to the 2nd power. 10 to the 2nd power can be represented as 10 times 10. 10 times 10 equals 100. So I am multiplying 7 times 100. 7 times 100 gives me a total product of 700. Another way I can do this is I can look at what my exponent is on my base 10. This 2 tells me that I will have 2 zeros, and then I multiply 7 times 1 to give me a product of 7. Put it all together, and my total solution is 700 for problem number 3. Flipping now to page 12, we're going to continue with the odd numbers 5, 7, 9, and 11 for on your own. Question number 5 states, the population of a city is 1 million. Write the number in exponent and word form. Just like we did in problem 1, we count the number of zeros, and this will tell us what the exponent is for our base 10. I count out that there are 6 zeros behind the number 1. And as an exponent, this becomes 10 to the 6th power. In word form, I write it out as 10 to the 6th power. For question number 7, we are multiplying 5 times 10 to the 3rd power. 10 to the 3rd power represents 3 factors of 10 multiplying against each other. 10 times 10 times 10. We know that 10 times 10 equals 100. We are still multiplying times 10, and 100 times 10 gives us a product of 1,000. So for this problem, we are multiplying 5 times 1,000 to give us a total product of 5,000. Another way that I can examine this problem is if I look at my 3 as my exponent on my base 10. That tells me that I have 3 zeros. Then I multiply my first 2 numbers, 5 times 1, and that gives me a product of 1 for a total product of 5,000. Either way that we go about this problem, the solution is still 5,000. Next up, question number 9 asks us, what is the value of n in the equation 10 to the 4th power equals 10 times 10 to the nth power? So we are trying to figure out what the value of n as an exponent is. This is our algebraic thinking, solving the problem to find the unknown, in this case represented by the letter n. In this problem, it shows that the breakdown of 10 to the 4th power represents 4 factors of 10 multiplying against each other. 10 times 10 times 10 times 10. We can also represent this as 10 to the fourth power is equal to 10 times 10 to the first, second, third power. 10 to the third power. So now that we have our equation that looks like this, 10 to the fourth is equal to 10 times 10 to the third power. This looks a lot like the question asking us 10 to the fourth power is equal to 10 times 10 to the nth. The value of n is 3, as we are finding that it is 10 to the third power. Last for this lesson, we are going over question number 11. A local business raised 8 times 10 to the second power dollars after 8 days, and 1 times 10 to the third dollars after 10 days. How much money did they raise in the last 2 days? For this problem, we need to first identify what is the value of 8 times 10 to the second, which they've earned in the first 8 days. And we need to find what is the value of 1 times 10 to the third power, which is their total after 10 days. Then we need to figure out what the difference is between the last 2 days. To start off, 8 times 10 to the second power. This 2 tells me that I have 2 zeros at the end of my equation. I multiply my first numbers, 8 times 1, to give me a product of 800. After the first 8 days, the company raised $800. By the 10th day, they had raised 1 times 10 to the third power. This 3 as an exponent tells me that I have 3 zeros behind my answer. Now I multiply 1 times 1, which gives me a product of 1. After 10 days, the company has earned $1,000. Now I need to figure out how much money they raised in the last 2 days, from day 8 to day 10. To figure this out, I'm going to find the difference by subtracting 1,000 minus 800. As I regroup, and this becomes 990. Pardon me. So as I subtract 0 minus 0, 0 minus 0, I borrow or regroup my thousands into my hundreds place to have 10 hundreds minus 800 leaves me with a difference of 200. The company earned $200 in the last 2 days. Now, if I want to write that as an exponent, I can change 200 into 2 times 10 to the second power. That is another way of representing 200. This concludes our video on HMH into math for 5th grade. I'm Mr. Chambers, and I thank you for taking the time to watch this video to improve your math skills. And I look forward to speaking to you again in our next lesson, where we will be covering Module 1, Lesson 3.